Here's integrated 2. It's section 1.1, problem 10. So problem 10 is asking you to graph the function and compare the graph to the graph of f of x equals absolute value x. Describe the domain and range. So it's asking you to do three things. You're going to graph the function, you're going to compare it to absolute value x, and then you're going to describe the domain and range. So first we'll start with the graph. So we're supposed to graph the function g of x equals 3 times absolute value x. So I usually just make a table. I know absolute value, it looks like a V shape because that's the parent function of absolute value, and that I've memorized that. But even if you don't know what shape it is, you can always plug in a point. The easiest points to plug in are -1, 0, and 1 because they're easy to calculate with. So the absolute value of -1, I'm plugging it in, is 1, and 1 times 3, that gives me a 3. So that means I can plot a point at -1, 3. If you don't have grid paper, don't bother doing the graph because it's not a proper graph without the grid lines. 0, 0, and then 1, 3. Because people are just giving V shapes with no scale on them, and that's not answering the question. It's not a complete graph. So this is the x-axis, this is the y-axis. Now this is a graph that I can look at and I can compare it. See, it's important that I put these dots here because that shows me this is 1, 1, 2, 3. That's 1, 3. It's -1, 3, and that's 0, 0. Those need to look like points on your graph. If you just have some V with no grid lines, and if I look at this table and they don't look like they're even on the graph, that's not a proper graph. So, but this graph will work. I have to compare it to the parent function. The parent function is just the graph of y equals absolute value x. Actually, in the first video that I sent you, I talked all about the different transformations of the graphs, so you can go back and watch that if you need to. This graph looks like this. So how is this graph, how does it look compared to this graph? I think it looks like it got, it's narrower. So this is, we call that a vertical stretch, and so your book teaches all that. If you read on page 6, if you read everything on page 6, it'll kind of tell you all about that. So we're going to say we have a vertical stretch of 3. And we're going to say it didn't get shifted right or left, and it didn't get shifted up or down. It's still at the origin. So that's all that there is as far as comparing it with the graph of f of x. And then we have to talk about the domain and the range. Domain are the x values, and this is the x-axis. So I see that it has arrows pointing left. Well, they're pointing up, but they're also pointing left and right. So that means that the domain is all real numbers. And the range are the y values. So there are no y value, this is y-axis, there's no y values down below 0. So we have to say y is greater than 0, or greater than or equal to. Alright, so we're done. So we sketched the graph. We talked about how it compares with the parent function. And we gave the domain and the range. And if you need more information, you can watch the first video that I sent.